part D, we are asked to find the maximum height of the ball and explain how we found it. So if you remember the graph of this, what we had was an upside down parabola. So the maximum height there would be the output of the point there. The input would be the time at which it reaches the maximum height, and the output, h of t, would be the maximum height that the ball reaches. So this pi point is called the vertex of the parabola. And one way to find the vertex is in two steps. Step one would be to just find the input of the vertex. And then once we find the input of the vertex, we can plug it into the original equation to find the output. So it turns out that with any equation of the form ax squared plus bx plus c, notice we're not using x, we're using t, and instead of y, we're using this function notation h of t. But nonetheless, if you wanted to find the vertex, you start by finding the x value of the vertex. Think of the vertex as a point. The vertex will have an x and a y. In my case, it won't be x, it'll be t for time, and instead of y, it'll be the height, h of t. But nonetheless, the x value of the vertex can always be found by taking the opposite of b, meaning change the sign on b, and then dividing by 2 times a. So in my problem, you may notice that the a value, the number in front of the quadratic term here, is negative 16. So my a is negative 16. And then my b is the coefficient on x. In that case, it's 40. Again, we're using t instead of x. But nonetheless, b would be 40. So this would give me just the x value of the vertex, or if you want, the t value, which would represent the time at which we get the maximum height of the ball, which isn't the question, but it's one step in that direction. So where I have x here being negative b over 2a, I would be taking the opposite of b. b is 40. So the opposite of b, which is negative 40, and then divide that by 2 times a, where we already said that a was negative 16. So you can do this on a calculator if you need to. Two negatives, when being divided, make a positive, and you'd have 40 divided by 2 times 16 is 32. So 32 goes into 40 one time with 8 left over, so you'd have 8 32nds, or 0.25. Be careful if you're going to do this on a calculator, in that you would have to put parentheses around the 2 times a. So if you're going to type this in as negative 40 divided by 2 times negative 16, you would have to put parentheses around the 2 times negative 16. So if you want, you can use a time symbol, but you have to have parentheses around the 2 and the negative 16. Otherwise, the calculator will only divide by the 2, and it'll think the negative 16 is in the numerator. So if you do this, you get 1.25. More importantly, though, what does the 1.25 mean? In general, it's the input of the quadratic, so we use x. But in my case, the input wasn't x, it was t. Sometimes I like to write it instead of x equals negative b over 2a. I like to think of the input of a vertex of a parabola is equal to negative b over 2a. And then I don't specify what the input variable is. So in general, we call it x, but in our problem, it was t. So this tells me when the ball will have a maximum height. This tells me after 1.25 seconds. So if this was my input, it would be 1.25 seconds, and that would be when I get that height. So if you wanted to put some coordinate axes, this would be my time. And now I'd have to figure out what is that maximum height. But now that I know the time it reaches its maximum height, I need only replace the t values in the original equation with 1.25, and that'll tell me the height of the ball at that time. So the next stage would be to find h of 1.25, and plugging that into the original equation would be negative 16, and then t is being squared, and then I have plus 40 times t, so that's plus 40 times 1.25. And then don't forget that the equation necessitates that you add 80 at the end, and whatever this comes out to be would be the height of the ball in feet above the ground. So I'm going to use my calculator to do this. It is possible to actually just store this into a variable, or now that you typed it, you could actually just use the previous answer feature wherever you see 1.25. But since 1.25 is easy to type, I'm going to do it the way where I just type it in. So I typed in negative 16, 1.25 is being squared, and then I have to add 40 times my input, which again is 1.25, and then don't forget that we have that constant out there of 80. Now, sometimes the hard part is remembering what this represents. The answer is 105, no big deal there, but the hard part is to remember what is 105. It is the output when the input is 1.25. Remember, my input was t. So when the time is 1.25 seconds, then the height of the ball would be 105 feet. So I should be using function notation here. So if you want h of t, the height that the ball is above the ground, is 105 feet. It's nice to point out that h can't be 105 because h is just the name of the function.